In the initial episode, we witnessed the utility of mathematics in forensics, especially in determining the time of death. In this subsequent episode, we'll delve into the value of mathematics in crime investigation and its aids in the detections of lies. As a recap, Adam came home discovering his partner was dead on the floor. 10 minutes later, the head detective Jed and the coroner Alex arrived to the scene to commence the investigation. Utilizing Alex's mathematical expertise, she employed her skills to determine the approximate time of death. She began by analyzing the function that relates human body temperature to the time of death. Uses two specific data points where she measured the temperatures of the body at two different times, and then she arrived to the conclusion that the victim had likely passed away at approximately 5:20 p.m. Jet was following all the calculations, but he's still curious about the derivation of the functions. Why is it the function that we could use in this case? Let me explain it, Alex said. So the Newton's laws of cooling says that the rate of heat change of a body is directly proportional to the difference in the temperatures between the body and its environment, which is illustrated by a differential equation where K is a constant of proportionality and T sub A is the ambient temperature or the room temperature. Well, actually, this differential equations in calculus is called a separable differential equations, and there's a method that can help solve this type of equations. Given a general separable differential equations, one can solve this equation by separating the two functions f of big T and g of small t to both sides, and then integrate each of the sides, finding the antiderivative to solve for the unknown variable. Applying this method to this function, Alex moved the term t sub a minus t to the left side and d sub small t to the right side. Then she integrates each of the sides, finding the antiderivative of each of the functions, and then she isolates big T to one side and everything else to the other side in order to solve for the function big T. At this point, how can you solve for C? How can you find or how can you formulate the constant C using the initial value? So if there's initial values given the temperature of the body when T is equal to 0, at this point, as a reminder that this data point is the temperature of the first time that Alex took the victim's body temperature for the first time. She replaced 0 into the small t, big T's of 0 into the big T, simplifying the term e to the 0 to be 1, isolating C to one side, she got C equals to T sub A minus T sub 0. So which means the constant C here is a difference between the ambient temperature and the initial human temperature. Plugging the C value into the earlier function, she arrived to the function that she used earlier in the analysis. At this point, Jet totally understands what's going on, how this function could be used, and how this function could be derived. Got it. Thank you. Then he asked Adam simple questions. Adam, what time did you last see the victim? Adam paused for a few seconds, trying to recall his memory. He said, "It was around 6 p.m. I left to meet with a friend for dinner." Then Jet engaged in a conversation with Alex right after to discuss his recent discovery. He said, "Based on our current findings, I believe that Adam is likely being untruthful. Alex said, yeah, the math shows that, but we do need to gather more evidences before making a conclusion. Mathematics is valuable in crime solving, providing objective tools for analysis and inference. In this case, it aids in estimating the time of death, identifying the correlation between time and human temperature, and generating leads regarding Adam's testimonies. Nonetheless, accurate conclusions require the careful consideration of both mathematical findings and human judgment, accounting for potential biases.